Welcome, everyone, and we'll go ahead and get things started. I'm David Dixon, a meteorologist and TV engagement coordinator with the nonprofit Covering Climate Now. Thanks for joining us this morning, this afternoon, this evening, wherever you might be joining us. And for those of you that might be new to Covering Climate Now, we are a global collaboration of more than 500 newsrooms across 60 countries. We're organized by journalists, for journalists, to help us all do a better job in talking about climate change and its local impacts to our audience. Head to our website, coveringclimatenow.org, to learn more and sign up for our newsletters and newsrooms trainings, including what you're seeing today, all of which are free of charge. I am thrilled to be joined here today by a fellow meteorologist and colleague who will help moderate today's discussion. Shel, over to you.
Yeah, howdy, friends. Shel Winkley. I'm a meteorologist as well as the weather and climate engagement specialist here at Climate Central. If you're unfamiliar, we're a nonprofit, non-advocacy organization of scientists and communicators dedicated to research and reporting and storytelling around the data and the science of climate change. Here at Climate Central, we develop and distribute compelling broadcast and publish-ready climate content for you, helping to empower your forecast, your stories, and your content to help make that critical link between extreme weather events and human-caused climate change to your audiences.
Thank you so much, Shel. Good to see you again. And thank you all again for joining us for our second Prep Your Climate Coverage webinar. It's a seasonal series dedicated to providing resources and accessible language that you can use when covering the upcoming season's anticipated climate driven extreme weather events. This session is going to be highlighting emerging climate research on hurricanes and heat, explore how journalists have reported on the human impacts of these events, and offer vetted language that's going to be essential to help your own reporting. Often, climate change coverage is reactionary, with journalists and meteorologists scrambling for relevant research and climate information, often in the immediate aftermath of an extreme weather event. Our goal in these sessions, offered in the summer, fall, spring, and winter, is to get ahead of this so we can more quickly and effectively make the climate connection in our own reporting. Good news is this webinar is being recorded, with the video and a recap being available to you all in your colleagues that couldn't make it to us later today or later on this week. We're also going to have plenty of time for your questions. Go ahead and submit yours via the Q&A button at the bottom of your screen, and please include your name and the name of your news outlet. We're going to be reading them out for the panelists to answer later on in this hour. While this webinar is open to everyone, please know that we're only going to be taking questions from working journalists and meteorologists only today. An additional note and an exciting note for those of you joining us: if you're looking for fresh ideas or want to brainstorm story angles or just need to clarify anything from today's webinar after you absorb it for your own climate change and the summer extreme weather coverage, we're going to be hosting office hours this Friday from 1:30 to 2:30 Eastern U.S. Standard Time. Feel free to join Shel and I during this time for pretty relaxed come and go as conversation. There's no pressure. It's just a great opportunity to ask questions, swap ideas, connect, and chat along with us. You can go ahead and register for that right now using the link in the chat. Now, it's my pleasure to introduce our panelists who are going to help Shel and I today. It is a stacked lineup. I am so glad that they are here for us today. We have Shannon Osaka, a climate reporter from the Washington Post. Previously working for GRIST, she has analyzed federal climate policy and extensively has covered the far-reaching impacts of climate change in the clean energy transition. We also have another meteorologist, Ariel Rodriguez, broadcast meteorologist at Telemundo 51 in Miami. In addition to forecasting hurricanes and other extreme weather events in Florida, he also produces a weekly series about climate and the environment. And finally, we have Daniel Gilford, a climate scientist at Climate Central, where he works on climate change attribution to support the organization's real-time climate and sea level teams. He's the lead author of the peer-reviewed study, Human-Caused Ocean Warming Has Intensified Recent Hurricanes. It's a fascinating field and fascinating science, which we're going to be exploring more today. Go ahead and join me in giving all of our colleagues a very warm virtual welcome. All right, so let's dive right in. Unseasonable warmth is already here for many of us. And if there's something that unites us all, it's that we're all facing increasingly warm temperatures all across the world. Billions of people are suffering from these heat waves driven by fossil fuel pollution, adding heat trapping gases to our atmosphere. Extreme temperatures are no longer a 1 day, 1 week, or 1 month phenomenon. They've become the new abnormal. 2024 was officially the warmest year since record keeping began back in 1880, breaking a record set only the year before in 2023. Globally, we've reached an average temperature of 1.54 degrees Celsius above pre-industrial levels, marking the first time that the world has temporarily crossed that critical 1.5 degrees Celsius threshold we've strived so hard, or not hard, to stay below. But consider just how much warmer the Earth would be if it wasn't for the fact that nearly 90% of the world's excess heat is absorbed by our oceans. This, however, comes at a great cost, with significant disruptions to marine ecosystems, acceleration of sea level rise, and of course, record-breaking water temperatures that are fueling stronger hurricanes and tropical systems. Thanks to advances in attribution science, which we're going to be exploring much more into detail in just a moment, we know that the hurricanes in the 2024 Atlantic season, including Helene and Milton, were influenced by this added heat in our oceans. So how exactly do we know this? Well, it's backed up by that field of climate science called attribution. Shel, take it away.
Yeah, so let's dive into attribution science, because I think maybe some of us have heard of it before, some of us have used it before. But let's kind of give you a primer on what it is. So in our careers, I think whether you're a meteorologist or a journalist or a reporter, we've likely had this moment. You're covering a big weather event, a record-breaking heat wave, a hurricane that rapidly intensified, and somebody asks you via email or out in public while you're grocery shopping, maybe in your social media contents, like, is this because of climate change? And for a long time, reporters, meteorologists, and even scientists were hesitant to connect any individual event with climate change, and instead would just use general language that kind of pointed towards global trends. And that is a great place to start. And we could say, well, this is consistent with what we expect in a warming world, right? But maybe that didn't always land for a particular event, or it didn't help tell that whole story. So that's where attribution has really come in. It's helped kind of make these vague events understandable and more concrete. So it's a tool that helps us understand that question. It's more clearly, more confidently, in a way that connects what's happening globally to what's happening to the place that you're reporting for, the place that you're covering or forecasting for. It takes that global aspect of climate change and it brings it down to your local impacts. Attribution science looks at whether and how much climate change played a role in a specific weather event. The science can do this by running climate models and compare two versions of the world. Basically, the world we're living in now with all the historical extra greenhouse gas that we of humans have pumped into the atmosphere since the beginning of the Industrial Revolution. And then we run that same science with a world that would have existed without human-caused warming. And then by comparing these two scenarios, we can figure out how likely an event would have been, or maybe would have not been, without climate change, and how much more intense it became. So we can say things like a heat wave was made 3 times more likely because of climate change, or ocean temperatures underneath the specific hurricane were made up to 800 times more likely to be unusually warm due to carbon pollution. Or maybe one of the strongest statements we've seen in a while from World Weather Attribution, that they said back in July of 2023, extreme heat was virtually impossible to occur had it not been for the fossil fuels that humans have put into the atmosphere, that have burned and then put that carbon pollution into the atmosphere, warming our atmosphere. So as communicators and your community's trusted messengers, this is an exceptional, useful tool. Attribution science moves the conversation from, is climate change happening, to, here's how it's affecting this specific event in this specific place. It makes climate change personal, immediate, and relevant to your viewers and your readers. It helps audiences understand that climate change isn't just happening to polar bears or to the Arctic, which is also very important, but it brings that future problem home. It's shaping our weather and our communities that we're facing right now. And the more that we can make those connections clear, then we're better equipping people in our communities to prepare, to respond, and to push for solutions. So we'll be sharing 2 of Climate Central's attribution tools with all of you. that will help you analyze climate change's fingerprint on daily temperatures, and another which will inform us on the role of climate change influence on the intensity of hurricanes. So let's start there. One of the big topics we're going to be covering today is going to be hurricanes. And we'll start with last year. Here at home in the US, we experienced 27 separate billion-dollar disasters. These events are growing more frequent and more intense as the planet warms due to human-caused climate change. Among those disasters, 5 specifically were caused by hurricanes. Helene and Milton dominated the headlines and the stories we scrolled past and that you produced, unleashing catastrophic flooding from the coast of Florida to the Appalachian Mountains of North Carolina, and also setting records for extreme rapid intensification in the southwest Gulf of Mexico. So starting with what we know generally about climate change and the influence on tropical weather, let's just bring it down to those basics that we understand, that we can see the trends. Unusually warm sea surface temperatures are a fundamental driver of tropical cyclogenesis and intensification. And as these water temperatures continue to rise, the implications for hurricane strength and behavior are becoming increasingly evident. So we'll start with rapid intensification. If you need a definition for it, it's defined as the increase in maximum sustained winds of at least 30 knots or 35 miles per hour within 24 hours. And it's not an anomaly, right? A study posted to nature.com found that roughly 80% of major hurricanes, anything from a category 3 to a category 5, now undergo rapid intensification more often during their life cycle. And it's not new. I think that's what's very important. It's like rapid intensification has always been a part of hurricane behavior, but the trends show that the number of tropical systems that are undergoing this process is increasing. Additional research shows that since 1979, human-caused warming has increased the global likelihood of a tropical cyclone developing into a major hurricane, category 3 or higher, by about 8% per decade. From 1980 to 2023, 177 Atlantic landfalling tropical cyclones rapidly intensified past the threshold. 39 of those storms, about a quarter of them, met the criteria for what we call extreme rapid intensification. And this is one of those newer terms that a lot of folks say, well, I've heard of rapid intensification, but maybe never extreme rapid intensification. So what that is at least gaining 50 knots or 58 miles per hour within that 24-hour or less period. These high-end intensification events can be particularly dangerous due to the short lead time that they can provide for forecasting and public preparedness, as they happen, if they happen close enough to impact a shoreline. Something that one of our colleagues, John Morales, mentioned many times over last year, was a big concern of his. The Atlantic Basin has seen a sharp rise in storms that rapidly intensify from tropical storm or category 1 to a major hurricane status, more than doubling from 2001 to 2020. And that's compared to the average that we saw from 1971 to 1990. It's driven by climate warmed ocean waters. And looking ahead, IPCC reports that they project a global increase in very intense hurricanes. So we're talking category 4, category 5. And it's not just hurricanes, right? It's cyclones globally, along with a potential month-long extension of the Atlantic hurricane season by century's end, adding more times for storm to form in conducive conditions, and adding more times that potentially you have to cover these tropical events. Again, these are the general things that we know about hurricanes and climate change. And while we know that a hurricane is going to hurricane regardless, because that's the weather side of things, right? We're not saying climate change caused this hurricane to form, but we can utilize extreme weather attribution science to understand how human-caused climate change is influencing the unusually warm sea surface temperatures, which a hurricane then will feed from and boost the intensity of that hurricane potentially. It takes that natural disaster and it turns it into something that could be unnatural. So let's talk about the attribution science and how we can do this. So I want to first bring in Dr. Daniel Gilford. Daniel, let's start with here. Let's ask 2 things. My first question for you is, how do we know that hurricanes are getting stronger due to climate change warming the water that these hurricanes are feeding on or passing over?
Yeah, so we know that hurricanes are almost like the engine in your car. They are giant engines that take energy in and then convert that energy into wind. And the way that they do this is sort of taking that warmth that comes right off the sea surface and then sucking up that warmth into themselves, converting it into wind, and then devastating an area. We call this theory potential intensity theory, and it has this idea that we can put a speed limit on the rate at which a hurricane can spin. So a hurricane is going to be able to spin faster if it has more fuel available to it. So as these sea surface temperatures continue to warm across our planet, we are seeing more tropical cyclones have stronger intensities associated with these because the speed limits of the storm are going up. So storms can actually reach higher intensities than they otherwise would have been if we hadn't warmed the planet.
Okay, so that's what's happening underneath the storm, right? But we know that there are other factors at play when it comes to these huge storms, right? Hurricanes are complex weather systems. So how do we incorporate other impacts to the storms into this attribution?
Yeah, so one of the things that we don't do right now with our hurricane attribution is we don't consider wind shear and how changes in wind shear could affect the storm. The other thing is that as the atmosphere itself warms and moistens, it can actually stabilize these storms a little bit. You can imagine an air parcel that's rising up, but it'll rise as long as it continues to be warmer than its environment. But as the atmosphere itself warms in response to human-caused climate change, it can actually decrease how unstable, how much rising that those air parcels undergo. So there's this sort of competition here between these warm ocean waters that we know are being increased. As you mentioned before, 90% of the heat is being trapped in the ocean. So we know these sea surface temperatures are getting warmer, but they're competing against the warming atmosphere, which would tend to stabilize the storms. And so we call this stabilization non-local damping because it's really warming across the planet that tends to warm up the temperatures that these hurricanes can see and stabilize. But in the end, we are finding generally more often than not, the sea surface temperatures are winning out and causing storms to increase in their intensity as we move forward in this century.
Thanks. Yeah, and I think that's an important point to note again, right? So we have this stabilizing portion of climate change that's happening above the storms, but we're still seeing so much extra warmth that's being added to our oceans that they're still allowing these storms to be stronger than what they would have been in a world without climate change.
Right.
Perfect. And if you have more questions about attribution, feel free to put those in the Q&A and we'll try to get to those in this session. I want to switch over though and talk about covering tropical systems and covering hurricanes. So Ariel, I want to ask you, as a broadcast meteorologist in a very hurricane prone Florida, how have you explained climate change's influence on storms to your audience and in your weathercasts? And I think particularly what I'm interested in knowing is, this is a part of a storm, but as that storm is, bullseyeing towards Florida, how do you handle that information?
Yeah, that's a great question. And let me start by saying that in my case, it's all about having the best opportunity to talk about it. For example, every year we work on a hurricane special. It's like an hourly hurricane special. So I am the one that always comes up with the climate change link to hurricanes on that special. And I make it a point to talk about it every year. For example, when I started back many months ago, and I brought the idea, my first take was to explain, the main connection. So I used the IPCC reports. I talked about, how hurricanes could be linked to climate change based on this research. And then I moved on. I started talking about the sea surface anomalies. I talked about the role that played in rapid intensification before it used to be a thing. And then year by year, nature sadly was giving me examples that I could use to talk about. For example, I talked about Harvey and the incredible damage it did in 2017, Ida in 2021, Ian in 2022, and then this last year, Helene and also Milton in 2024. I also linked that to the increased risk for storm surge and the increased damage that storm surges might cause due to sea level rise, especially in our area, and also using examples as we saw in the West Coast this past few years. And I also talked about the devastation that Maria, for example, caused in Puerto Rico. We did a special and we traveled to Puerto Rico and we called it Island Without Beaches. And because the devastation and the erosion has been extreme to the point that you saw buildings collapsing into the ocean, and that was very dramatic. So it was used as a good example of the power of nature linked to climate change. And another topic that I like to talk about, I like to link stuff to nature itself and the ecology of things. And we know that when we are ravaged by a hurricane, ecosystems take a long time to recover. We've seen that all in Puerto Rico, in the Caribbean. So I did a story about how different ecosystems recover, it being the corals, which we need here a lot, especially to protect itself from the surge, the mangroves, the rainforest. And it attracted a lot of attention because it's something that usually people don't think of. And in terms of the day to day, whenever we start seeing episodes of rapid intensification, I always make a point to signal those examples and say, well, this is, we have anomalous sea surface temperatures. They are, this much more than they should be. And I always make a point on my day-to-day basis when I have those examples specifically to draw in climate change into the conversation.
Perfect. Thank you. Yeah, the ecology part's interesting to me. Weird plug is this. I've got a book behind me. It's called Hurricane Lizards and Plastic Squid, and it talks about how nature has adapted or moved as the climate's changed. And the hurricane lizards are in the Caribbean, Puerto Rico, the Dominican, and they've actually evolved to like be able to hold on to the trees better because of the hurricane winds have increased. So I always think that that's interesting to see how nature is evolving, and also, like you mentioned, like how it's changing because of these hurricanes. All right, Shannon, I want to bring you in now. There's a lot of focus on when the storm strikes, but often the aftermath can be just as deadly. And that story continues beyond the storm itself, right? Especially for vulnerable populations. And I'm personally interested in this because I'm in Texas. I was impacted by Hurricane Beryl last year. And I think you and your colleagues found something that was incredibly interesting and incredibly helpful to know for future storms after Beryl made its impacts in Houston.
Yeah, this was a really interesting story to report because we had been hearing from experts like energy grid experts and meteorologists for a while that one of the biggest risks of a hurricane, Beryl wasn't even a very particularly strong hurricane. I mean, compared to some things that we've seen, but is the risk of a power outage and then the compounding events that happen after this. So we were kind of reporting on this issue and looking into it before Beryl hit. And I was actually traveling in Boston at the time, and I got a call from my editor that said, hey, you have to stop everything that you're doing and you have to go to Houston to report out this story. And what we found was just, after Hurricane Beryl hit Houston, some people were lacking power for 7, 8, 9 days. I got there on day 6, and there were people who had not had power, since the previous week. And we covered the effect that was having, particularly on vulnerable populations. There's about 2.5 million people in the US today who make use of some sort of powered medical device. It could be like an oxygen tank, it could be a dialysis machine. And a lot of times they have that device in their home and they rely on it. When you have a situation where you have a hurricane come through, knock out the power, and then you have, as we saw after Beryl, fairly extreme heat. It wasn't even the most extreme heat that we could have seen that goes on for several days. People are in seriously dangerous conditions. So my colleagues and I were going around Houston. We were meeting with people who were affected by this, who were out of power for 8 or 9 days. And also talking to, medical professionals who were working on holding down the ERs, and just seeing the chaos that happens when you have all these people who have additional medical devices and needs flood into the system. Then you have extreme heat. It just becomes one of these compounding disasters that can be really devastating. We also pulled like thousands of text messages that people had sent to local NGO organizations trying to get help, saying things like, I don't have diapers, I'm stuck at home and disabled and I can't care for my children, or I don't have water available to me, I'm missing medications that I can't take. So it was a really powerful reporting experience for me of just seeing, when one of these storms hits, some people are able to leave immediately. If you have a car, if you have the means, if you have the ability, you can leave, drive 2 hours, maybe get a hotel. But for the people that are left behind, it can be particularly devastating. And that was the story that we tried to tell with Beryl.
Great. Yeah. And interesting as well, because just a couple weeks before that, right? A lot of Houston was without power before Beryl because of the big derecho that came through. So, all right. So one of the things we want to do here is to give you language that you can use in your reporting. So we want to offer up some language that as you're doing these stories, this is one of the you can tie to hurricanes and tropical systems. The science research is clear that climate change supercharges hurricanes, increasing their intensity, rainfall, and storm surge. And then we also want to give you some story ideas as you're thinking about your coverage moving ahead or as we get into the season. So for our story spark or coverage ideas with this, we recommend diving into how tropical storms are impacting home insurance. And that's not just on the coast, but inland as well. Follow up on stories of resiliency and recovery in impacted areas, exploring how evacuation plans may need to change, and of course, highlighting those inland impacts of tropical systems, how they're far-reaching, they can be deadly, much like we saw firsthand with Helene. And then some of the resources, I think this was really interesting last year when we were talking about Helene and Milton. A reporter that I talked with in Miami said, like it always feels the same. A big storm's coming, we write about that, disaster's forming, something really big happens, the storm hits, and then the aftermath. So before we switch gears, I want to give you a few resources that you can utilize during and after hurricanes that can really help tell the story. The first of which is that attribution science we talked about for sea surface temperatures. It's called the Ocean Climate Shift Index. It's Climate Central's attribution tool to understand climate change's influence on sea surface temperatures. So the scale here runs from -1,000 to 1,000. It's a big bin because it takes a lot to change the water's temperature, right? Showing how much more or less likely ocean temperatures are that could turn a natural disaster or hurricane into an unnatural one. And I want to give you a very quick example of how Ginger Z, chief meteorologist and climate correspondent at ABC News, used this tool in just around 30 seconds.
Here in Tampa, as we prepare for Hurricane Milton, we wanted to take out the climate connection and make sure you have that clear understanding. Yesterday, as we were watching the pressure drop and the wind speeds intensify, people said, now, how's that happening? First of all, it's going to run into some wind shear before it makes landfall, and that's why we have it going down in category. Still going to push a lot of water, but the water temperatures are 4 to 5 degrees above normal. Climate Central, a group that does this thing called a Climate Shift Index, says that the water in which it formed and rapidly intensified is up to 800 times more likely to be that hot and that incredible fuel for a storm like Milton.
Okay, and then one other tool I want to share with using this hurricane attribution that we talked about. As tropical storms and hurricanes develop and intensify this season, you'll be able to come to a website that looks like this. This is purely an example, but it will look exactly like this to give you an understanding of how climate changes influences storm at any point along its timeline. So in this hypothetical storm, we named it Hurricane Shell in the year 2050, because Daniel and I were talking, if we make it to retire all the S names and end up at Shell, then I think that we potentially see the impacts of climate change, right? So Hurricane Shell 2050, at the top, you'll find the numbers you need for reporting about the increase in wind speeds attributed to climate change, how and if the intensity was boosted, and exactly how much more likely the water temperatures were that fed the storm through the intensification. This will allow you to get further information and visuals to share in your reporting and your forecasts. Throughout the season, you'll be able to see both of these tools. Climate Shift Index Ocean is already there. This will be up once the first tropical system occurs, but you can find both of those at climatecentral.org.
Yeah, you're probably going to get a storm named after you, Shell, eventually down the line. They've already retired David, so fortunately, no storm for me. I'm really looking forward to seeing this in action this season because I think it's going to be an incredible resource for journalists, for meteorologists to quickly go to this page and get access to that data and get access to that language as well. I also want to quickly flag just some of the resources we have here at Covering Climate Now that may be helpful for those of you that might be new to the climate beat, or for anyone that wants to be better informed or better equipped to effectively cover these hurricanes, this summer's heat, or any of the various and far-reaching impacts of climate change in a way that will resonate with your audience. Our resources page on our website, coveringclimatenow.org, has a ton of these great reporting guides, including a summer reporting guide, debunking myths, how to make the climate connection, and a whole lot more. We also have a ton of newsletters that you can sign up for. For the TV folks present, I want to let you all know about our Climate Station training program. Over the past year, we've had reporters, meteorologists, producers really even entire newsrooms and local TV stations across the country, both in English and in Spanish, benefit from these free training sessions that are designed to help you report on climate in your market. To learn more about this program, once again, offered completely free of charge for local newsrooms, and again, offered in both in English and in Spanish, head to our website or go ahead and send us an email in that chat. Okay, before we move on to extreme heat, which I know we got plenty to talk about there, and just another reminder, we are going to have some time for Q&A at the end of this, so go ahead and use that Q&A tool at the bottom of your screen. We have to talk about the elephant in the room. We know that the National Weather Service and the agency that houses it, the National Oceanic and Atmospheric Administration, or NOAA, has been decimated by federal funding and personnel reductions by the current administration. In fact, in an open letter released just about a week or so ago, all former National Weather Service directors expressed their thoughts and their fears about what this means for forecast accuracy and ultimately public safety, writing, quote, "Our worst nightmare is that weather forecast offices will be so understaffed that there will be needless loss of life." This is a conversation that we are seeing firsthand with this spring severe weather season as well. But it's, as we head into hurricane season, starting in just around 10 days or so, it's impossible to predict just how much current and future disruptions to the agency will impact its effectiveness during this year's season. It's likely that we will see hurricane track and intensity forecasts take a hit, just a year after the National Hurricane Center set an all-time record for forecast accuracy throughout the 2024 season. It's vital that we continue to report on not only these reductions, but also the loss of vital data, with one noteworthy casualty announced earlier this month being the database that we showed you earlier this hour that compiled each year's billion-dollar weather and climate disasters, which has been updated since 1980 and is no longer going to be updated due to, quote, "evolving priorities, statutory mandates, as well as staffing changes." When covering this evolving topic, do rely on university experts, state climatologists, and others that are going to be able to talk about these impacts, as federal employees likely will not be able to. We do have an entire press briefing, both with us at Covering Climate Now, Climate Central, and the American Meteorological Society, dedicated to exploring why we need NOAA now more than ever. We have a link to that recording in the chat. All right, let's move on. As we are seeing warming trends across every season, we have to talk about this summer's extreme heat, as it's responsible for more deaths than any other weather event, killing more people most years than hurricanes, floods, and tornadoes combined. Heat exacerbates underlying illnesses, including cardiovascular disease, diabetes, mental health, and asthma. And even low and moderate intensity heat waves can impact the health and well-being of vulnerable populations, as extended periods of both day and especially nighttime temperatures create this cumulative stress on the human body, increasing the risk of illness and death from heat exposure. And this, again, is especially evident with vulnerable communities. As continued carbon pollution traps more heat in our atmosphere, summer temperatures are now arriving earlier and getting hotter, with new Climate Central analysis just released, I believe, this morning, finding that 242 U.S. cities examined found that summers in the U.S. have warmed by an average of 2.6 degrees since 1970. Now, this is an overall average across all the cities examined for the entire US, but some cities, such as Boise, the location, by the way, of this year's American Meteorological Broadcast Conference, have warmed over 6 degrees since 1970. By the way, both Shell and I are going to be there at that American Meteorological Society AMS Broadcast Conference in June. So if you're going there as well, go ahead and reach out to us so we can connect in person. But once again, it's not just about how much heat, but also how long, as their data, Climate Central's, also shows that most cities are seeing an increase in the overall number of days with above average temperatures or above normal temperatures. 1 in every 5 cities now experience at least an additional month of hotter than normal summer days than it did back in 1970. again, these stretches of longer above normal heat is still dangerous, even if they don't get widespread attention, as it's not a quote record-breaking heat wave. Low and moderate intensity heat waves, again, can impact the health and well-being of vulnerable populations. So with that, let's dive in. And I want to hear from Shannon and Ariel about this. We'll start with you, Shannon. Back in 2023, you were in Phoenix reporting on that summer's extreme heat that impacted some of the city's most vulnerable residents. What exactly did you find there, and what tips could you give for those that are going to be covering the deadly impacts of the summer heat?
Yeah, I think what's so interesting about heat is that it really stratifies the population, right? You have people who are able to stay, as long as there's no power outage, you have people who are able to stay in their homes, they're completely secure, they have their air conditioning, they're safe. Then you have people who are unhoused, who are extremely vulnerable to heat. And you have people with particular medical conditions that can make them even more vulnerable to extreme heat and even more vulnerable to being unhoused. So I was in Phoenix reporting on folks with schizophrenia who are at a heightened risk of dying from extreme heat. It was pretty crazy looking at the numbers. Phoenix does a great job of tracking their deaths from extreme heat, which a lot of cities don't do very well. And there was a huge proportion of the deaths that they'd have had over the last few years were people who were schizophrenic. And that was both people who had schizophrenia and were unhoused and living on the streets, and also people who were housed, maybe with family, or people who wandered away from sort of a co-living situation. And we followed the story of this one young man named Stephen Goodwin who basically left his home. He was having an instance of psychosis, wandered through Phoenix for over a day, and ultimately died. And lots of opportunities where people tried to stop him, tried to help him, but ultimately he passed away. And I think that story was really interesting because it just showed us that it is this really, I mean, while this was going on, Phoenix is prepared for heat. Everyone has air conditioning pretty much, but there are certain populations that are much more vulnerable than others. And if all the ingredients are there, whether it's mental illness, being unhoused, all of these situations can lead to untimely deaths. And we're just going to see more and more of that. And the other thing about this heat wave in which this young man died is it was going on for days and days and days. And so what happens to your body is for a certain period of time, your body sweats. It has all of these functions to keep your body temperature down, even when it's 117, 118, 119. But if days and days of that exposure happen and you're being exposed even at night to really high temperatures, it's stress on the heart, it's stress on the body tissues, and eventually things start to break down.
One more quick thing. One thing I really enjoyed or really found impactful from your reporting, not only with this, but also that piece that we talked about earlier, is just going for the human angle. It's very common for reporters and journalists to just get caught up in the numbers, because even when you talk about the numbers, especially just the sheer amount of people that die from heat or are hospitalized due to extreme heat, you sometimes lose that these are people. Can you talk a bit more about, and maybe offer some tips of how exactly do you humanize this sort of unseen force? I mean, we feel it, but I mean, it's like summer. Of course, it's going to get hot, but it's deadly.
Yeah, I think that it can be hard finding those characters who can really illustrate the story to the fullest extent that you want to. It's not as simple as sort of, walking down the street and saying, how are you feeling about the heat? We have lots of different techniques that we use. Sometimes I'll work with a local NGO that is really involved in addressing this issue, and then they can help connect to some people that they're working with. That's what we did in the Houston story. You can also use Freedom of Information Act requests to great effectiveness. That's what I did in Phoenix in terms of looking through those death records and looking for individuals who had, this confluence of factors. And then it's a matter of, really talking to those families, seeing who some people don't want to relive what was a terrible experience for their family, but some people really do. They want to get that story out there and they want to help other people. And so it's just a matter of finding those families who really have that drive to share their story and share their experiences, and then trying to tell it in the most compassionate way that gives them the most agency that they can have over the direction of the story, and make sure that they're comfortable with what is going to be shared.
Thanks for sharing that. They're really great tips, and definitely recommend people taking note of that as we head into this heat that has already really started for a big chunk of the United States already. Ariel, over to you. Research shows that Latino communities often are disproportionately impacted by extreme heat. How do you and your newsroom at Telemundo communicate these increasing risks?
Well, first of all, by the forecast. Whenever we see that there might be a signal of a heat wave coming, I mean, we especially try to drive that point. We're doing that this week. We're supposed to reach 96 degrees today. We're at 89 so far, but the heat index it's almost at 100. So it's getting pretty hot up there. So, like for example, yesterday I made use of Climate Central's climate shift index to illustrate, the impact of climate change upon those temperatures that we had yesterday and the ones that we're expecting for the next few days. And also, we make it a point to humanize the story, as Shannon was saying and you were saying. For example, last year here in Florida, there was a law that passed, a state law that limits local government from enacting ordinances that require employers to provide heat assistance to their workers, especially the immigrants. We have a huge immigrant population that works in the fields in Homestead, and they have been affected and they will be affected this summer. So, for example, last year, not me, but I remember the reporters working on those stories specifically angled to the immigrant population and the workers that spend hours in the heat. So my best advice would be, as we already said, humanize the story, drive it home, get examples, put a face to it. We have so many people suffering from heat, and it's sadly not a balanced situation. It affects more people than others, especially depending on their income and their livelihoods, and also the work that they do. And I would prioritize that. And even when you have stories that deal with loss, you could use that as an angle as well. I know that right now cities and local governments are pretty limited in Florida. However, they are still working on helping communities by providing these cooling centers, shading initiatives, by increasing tree canopies in parks and like water access, fountains, pools, splash zones, things of the kind. So those are examples that can be used to try to tackle and show, what this can be doing. And also the health aspect. I've worked on climate stories, signaling the increasing health aspect of climate change, whether it's by heat, the increasing ozone levels in the lower part of the atmospheres as we have really high temperatures. This is also a problem that we see here in Florida during the summer months, and we see it in Texas as well. I'm pretty sure that Shell is witness to that.
And I think you brought up many great points, especially that heat doesn't impact us all in the same way. It's easy for a lot of us to talk about extreme heat, and we go from an air-conditioned house to an air-conditioned car to an air-conditioned workplace. But for a lot of populations, a lot of people, that is not the case. And it's vital that we really cover extreme heat with the quickness it deserves, because what we have seen and what we know from science is that extreme heat illnesses can happen very, very quickly. So once again, here is some vetted language from us here at Covering Climate Now and Climate Central that you can quickly use in your reporting to make this climate connection. And this is a pretty powerful statement. Every heat wave in the world is now made stronger and more likely to happen because of human-caused climate change. It's a pretty big, encompassing statement to make. However, this comes from a recommendation, not only from us, but also World Weather Attribution, because you can make this with the utmost confidence because there are years of attribution science to back you up on this. And it's imperative that we do make this connection. As I said before, heat is the #1 weather-related killer. There's more than 21,000 Americans have died from heat since the turn of the century, with emergency departments on average seeing at around 65,000 people suffering from heat exhaustion and heat stroke every summer. Statistics that are likely an underestimation. It's also a public health and justice issue, as we heard before, as people with disabilities, older adults, children, pregnant people, unhoused people, incarcerated people, and outdoor workers are some of those groups most vulnerable. For our reporting recommendations, or those story sparks, we recommend you dig deeper into how this heat disproportionately impacts these vulnerable communities and go ahead and examine how those cities are adapting to this increasing heat. And more importantly, where these cooling infrastructure or urban forestry projects, where are they being built? Are they in the areas that desperately need them? There's so many story beats out there that tie back into extreme heat. It's a threat multiplier from infrastructure, sports, energy use, politics, migration, workers' rights. Just for example, extreme heat intensifies and deepens drought, which in turn stresses agriculture, reducing crop yields and requiring farmers more to spend more on irrigation. But we also know that extreme heat, drought, and water scarcity are also main drivers for migration, sometimes not as a direct result, but potentially indirectly, as this extreme heat exacerbates economic insecurity and creates tensions that lead to conflict and ultimately displacement. The bottom line is it's never just a hot weather story. Just a final note on this topic and a recommendation from us at Covering Climate Now. It's easy to grab a photo of a crowded pool or a video of a kid enjoying ice cream when talking about summer heat, but it's much more accurate to use visuals that reflect the seriousness of the situation. I've seen this far too often in local reporting. So instead, opt for photos that show people struggling with heat, such as crowded cooling centers or workers struggling under heat conditions or people just trying to stay cool, or signage even highlighting these extreme temperatures. Remember, heat is the leading cause of weather-related deaths, and our coverage and our visuals should support that and not make light of it. Now, climate's fingerprint on heat isn't just there for these destructive large-scale heat waves that are declared by local and national meteorological societies, or rather services and offices, but also there for local scale warm days. More and more, we're seeing these heat waves smash records, which is a direct consequence of our rapidly warming world. Here in the US, by the way, we've had over 38,000 daily high temperature records broken at weather stations since last summer. Climate Central's Climate Shift Index, you saw it for oceans, now we're seeing it for air temperatures. It's a great resource that uses this attribution science that Shell talked about. Ariel used this, and it can help you make this connection during heat waves by quantifying the influence of climate change on these local daily temperatures, not only here in the US, but also across the world. Shell, do you want to explain it a little bit further on?
Yeah, and like Ariel, I've been living in a climate shift index world of 3s, 4s, and 5s for pretty much the past week and a half or so. So as mentioned earlier, we're taking a ratio between the world we live in now with the historical carbon emissions included and a world without human-caused warming. So a couple examples of what you're seeing here. The scale's shorter. It's a 0 to 5 scale, unlike that really big one we saw with Climate Shift Index Ocean. And that's because of the temperature variability that we can get. But it doesn't mean that the numbers are less impactful, right? So a CSI of 1, a climate shift index of 1, means that climate change made today's temperatures at least 1.5 times more likely to occur because of climate change. The higher the number, the stronger the influence. So a climate shift index or a CSI of 4 or 5 means that it's 4 to 5 times more likely, top of the scale. So the temperatures would have been extremely rare to almost virtually impossible without a fingerprint of climate change. Again, it helps to make that connection, to put climate change local, to make it real. And because it's peer-reviewed science, it adds credibility to what you're reporting. Being simple and visual, it fits easily into the forecast and reporting to help answer the curiosity of the heat in the moment and invite your audiences to dive deeper into the conversations, again, about resilience, preparedness, and what it means as we bring this closer to home. And as you can see there on the screen, we wanted to make this data accessible to you for your storytelling. You can easily bring this into your Mac system, your Barron's graphic system, or if you're a reporter or you're digital and you have a GIS system, we have a KML version of this data for both maximum temperatures and minimum temperatures that you can bring in daily to make that connection as well.
Thanks, Shell. This was a lot. We've thrown a lot of information that we've covered today at you. We've had some great insights, but Don't worry if you, again, forgot a stat or specific language, because once again, we have recorded this session, but we also have resources, including Clever and Climate Now's summer reporting guide, which we saw in the chat, but also Climate Central's summer reporting package as well. It's going to be both of these great resources to check back on throughout the season. I encourage you all to explore more of these, but also to stay updated through signing up for our newsletters and expand your climate knowledge. And once again, you can feel free to chat with Shell and I in that office hours on Friday. But before we do that, I want to get to some questions in these last 10, 15 minutes from you all. We did have a question coming to you from Barbara Moran from WBUR, I believe in Boston, that I think we want to just chat about a little bit. Is any idea if NOAA will be putting out a hurricane forecast this year? We didn't talk about this, but if not, where is the best place for reporters to get information? Shell, we've already kind of set up this time specifically right before NOAA is going to put out their forecast. I believe tomorrow, isn't that correct?
Yeah, tomorrow they'll put out their forecast, and I believe I got an email that said next week they're also going to have some interviews, which you can talk with some of the National Hurricane Center employees about your hurricane questions. Now, with that in mind, right, we kind of understand the situation, and we know that that may or may not, potentially may not, involve the climate change angle as well, and how that is going to influence this year's tropicals forecast, right? So this is where you can bridge that coverage. We can bring in the experts from NOAA and the National Weather Service because they are excellent at what they do, and we see every year how important they are. And then you can bring in this part of the story for your coverage, which is how climate change could impact the 2025 season as well.
Daniel, I just wanted to touch on this topic really briefly. You know, I'm not asking for your outlook or anything like this, but we know water temperatures are so vital for talking about a hurricane's intensity. And last summer, we were pretty much exclusively talking about just how record warm those ocean temperatures were in the Atlantic. They have backed off a little bit over the past year, but it's still incredibly warm. What advice or what insights can you give to folks talking about these record, no longer record warmth in the Atlantic, but still very warm waters and what it means for this season?
Yeah, the temperatures are still quite a bit warmer than they would have been in a world without climate change. That's kind of the top line results. And so we know that these storms, they can feed on this warmth as we were talking about earlier. And so I would say it's really important to stay vigilant, look at the Climate Shift Index Ocean tool that we have to understand how climate change is affecting those ocean temperatures that hurricanes are experiencing as tropical systems pop up, become tropical storms, and then hurricanes. Our landing page will provide information as to how those storms are sort of experiencing that those warm temperatures. But it's really important. You know, last year we had Hurricane Beryl in June that popped up and was facing temperatures that were more akin to what we expected in September. So this shifting in the season is something that we are also, you know, thinking about clearly at Climate Central. As we are moving into this hurricane season, we know that there's these warm temperatures can provide a catalyst for storms to become very intense very quickly, and even very early on or even later into the season when storms aren't expected to be as intense, but indeed are becoming that intense. So it's just important to stay vigilant, stay on top of this story, and look at how climate change is influencing those waters.
Thanks for that, Daniel. I want to go over to Shannon because I think most of us are coming to you from deep south. I think Florida, Texas. I'm in South Carolina, but Shannon, this is a question coming to you from the Portland Press Herald, Penelope Overton there. What tips or what information that you could add would be helpful for folks that are covering extreme heat or heat waves that are in colder weather states such as Oregon or Washington? We know they're not immune to this heat, but it's a little bit different compared to areas that are more used to this heat, such as Florida, Texas, or even deep south.
Yeah, that's a great question. I was actually living in Seattle when the big Pacific Northwest heat wave hit. I think it was 2021. And I think it's just an important thing to think about is just the preparedness is not the same. I mean, this was a heat wave that anywhere else besides the Pacific Northwest would have been a tiny, tiny blip. But nobody, like very few people have air conditioning. Very few people are even prepared to know what to do to go get a window air conditioning unit. So I think it's all about thinking about your particular community and what they're ready for and what they're not ready for, and then helping to provide, those more like consumer oriented, like solutions oriented pieces of like, here's what you need to think about when you have this big heat wave coming towards you. And people are just, they're not prepared to think about things in that way. And that's an area where I think this kind of like quicker turn journalism can be really helpful. And I think in the aftermath of that heat wave, there were also great stories just about, again, about the human effects for folks that were not prepared, had not been, they had not set up kind of adequate cooling centers for people who are unhoused. And that's another great area of coverage.
Thanks, Shannon. Okay, so we got a question from our friend Steve Glazier at NBC Connecticut. I want to tackle the first half of the question, and Daniel, maybe this is a good one for you. Speaking in the world of attribution, how long after a significant weather event can the attribution science tell us how worse or more likely the event was, right? So the tools that we showed you today, climate shift index, storytelling tool, that's going to be real time, right? That's in the moment. So when we talk about these big hurricane attribution studies, like we saw with the floods in the southern US a couple months ago, Helene last year, how do these work and how soon after can we do this?
Yeah, so the science has been evolving, especially rapidly over the past decade, to the point where we can now put attributable numbers on things like heat waves in a matter of hours or even in real time after while the event is actually still taking place, as we showed with the climate shift index. For other types of attribution, for instance, the attribution of Hurricane Helene's flooding that was caused by freshwater flooding, the rainfall coming down, that was a report that was put out by colleagues at Stony Brook and I believe at Lawrence Livermore Laboratory, and they were showing that I think a few days after the event. So it really just depends from event to event whether or not we can put these information out sort of in real time or quite rapidly. But the field has evolved to the point now where we can confidently put these peer-reviewed systems can confidently put attributable numbers on events in real time or just after the event in a lot of cases.
Yeah, Shannon mentioned that Pacific Northwest heat wave. That was one of the first big attribution reports, but it took a really long time to do. So that science now allows us to do it within weeks in order, because, if you do it a year later, that it's hard for people to remember it. We got just a couple minutes. I want to bring Ariel, maybe I don't want to put you on the spot on this one, but we had a good question from Angelique Redwood, just kind of asking about, have you found any statistical evidence or stories based around changing infrastructures for residential and commercial buildings, materials that promote cooler weather, basically the ways that we can make our cities more resilient? And Ariel, I ask you, and again, not to put you on the spot, but I know that there's a community in Florida called Babcock Ranch, which is basically built on renewables. They've put all their transmission lines underground, and hurricane after hurricane, they show that they can bounce back faster. So anything that you've experienced there in Miami or have seen that it potentially works in this regard?
Well, I've done stories about Babcock Ranch as well for the past few years, even when they were starting, and it was quite amazing. So that's a great example. And in Miami, for example, I've done a lot of stories on LEED buildings, places that have been built following specific protocols to use renewable materials, and also that use renewable sources like rainwater and even solar power. So that's a good example as well. I know I've done stories with Miami-Dade College that they have a new building. Well, they used to be new, not anymore. Back in the day it was, in which they use all of those resources. So that's also a great example of a story as well. And I wanted to add something else before we end. I know that we might be limited in official governmental sources right now. And I saw this during the past Trump administration when I used to do interviews at the National Hurricane Center, that many of their forecasters refused or pretty much did not want to acknowledge anything related to climate change. But there are many other sources. So build your sources, use this type of networks, contact local universities, and they might be willing, and they, in most cases, will be willing to talk about climate change without hesitation. So don't think that because of what some other sources, the door might be closing there. There's always doors opening everywhere else. So just make sure you look for those.
That is a great point. And if you have any questions that we didn't get to, or even want to chat about that further, of asking Shell and I if there's any experts that we would recommend, again, join us for that virtual office hour coming up this Friday at 1 to 30 to 2:30 Eastern time. I hope some of you will join us then. Once again, the link is in the chat to register for that. It is now 1 o'clock, so that is all the time that we have for today. I want to personally thank our wonderful panelists for joining us here today. I also want to thank my colleagues, not only at Climate Central, Shell, but also my colleagues at Covering Climate Now, Elena and Teresa, for helping me with the chat as well as these slides. I urge you all to sign up both for our newsletters at Covering Climate Now as well as Climate Central so you can stay informed. And I hope you'll join us for our next Prep Your Climate coverage session that is going to be coming up in September. This one is going to be focusing on the impacts climate change is having on our fall weather. Keep an eye out for that and an invite in September. And until then, thank you all once again, and be sure to stay in touch.